We're going to cover two things about imaginary numbers in this video. And imaginary numbers can be a little confusing at first with some of the stuff we're going to talk about. But hopefully the more that you practice it, the more we'll get used to working with imaginary numbers if you have not already. So sometimes you've got equations that they will leave you with a situation where you have to take the square root of a negative number, and you can't take the square root of a negative number. So the way that we define that is by using an imaginary number. So the imaginary, or the way that we denote an imaginary number is with I. And I is essentially saying I is equal to the square root of negative 1. So it's basically accounting for the negative aspect of a square root. But you just have to always put it. So when you're writing an imaginary number, say for instance you had the square root of, negative 36. The way that you would write that answer is by saying 6i. So the way that we denote that in general is using b as a fill-in for our coefficient. So the way that we write an imaginary number is like 6i, or just in general bi. And b is, like we just said, is the real number, and I is the imaginary part. So let's look at some examples of negative square roots. So here's the steps you're going to take for solving this. The first step is to rewrite your square root as, say for instance, it's negative a. You're going to rewrite the square root as negative 1 times that a. So you're going to pretty much separate the negative aspect of it. And then you're going to break down a if it's not a perfect square, and simplify the radical. And typically when you break it up as negative 1 apart from everything else, you can always take out some form of I, even if it is just I by itself. So I'll show you some examples of what that'll look like. So we've got number 1 is the square root of negative 9. We can't just straight up do that, so we have to account for it with an imaginary number. So the first step you're going to take is breaking apart the negative 1 away from the 9. So you're going to rewrite this as negative 1 times 9. And then we're going to take the square root of each of those. So the square root of negative 1 is just I, and the square root of 9 is 3, so our answer is 3i. And we'll do another one just so you can see, because these type of problems are a lot easier than some of the more complicated ones that we'll do. But number 2, we're taking the square root of negative 196. So we're going to break that up as negative 1 times a positive 196. Because now we can take the square root of each of these. So we're going to take the square root of negative 1, which is I, and the square root of 196, which is 14, I believe. Yeah. And those are 2 examples where it comes out evenly and it works nicely. So let's look at number 3. This is a case where you can always take out an I at the very least. So the square root of negative 5, we can rewrite that as the square root of negative 1 times a positive 5. We cannot take the square root of 5. We can't break that down any further, but we can take the square root of this negative 1, which is just I. So our answer is I times the square root of 5. Now, we'll look at 2 examples where they don't come out. They don't come out nicely, but you can break down the inside to where you can still take out a portion of what's inside your square root. So first thing you're going to do, if we look at number 4, is rewrite this as the square root of negative 1 times a positive 80. So we could go ahead and take out I. So now we've got I times the square root of 80, and we can break down 80 even further. So this would break down to I times the square root of 16 times 5, I believe. Yes, because 16 is a perfect square. That's the highest perfect square we can have in 80. So this would break down. We can take the square root of 4. So 4 would come out of the radical. I is still on the outside. And what's left would be 5. So your final answer would be 4i times square root of 5. You need to pause and write this down or write that down because I have to erase it to do number 5. All right. So on number 5, we have got square root of negative 32. So we're going to rewrite that as negative 1 times a positive 32. So immediately we can take an I out because the square root of negative 1 is I. So we can take an I out and we'll be left with the square root of 32 on the inside. But we can break that down even further. And that could be broken down as square root of 16 times 2. So then we're going to take the square root of 16. And I'll rewrite the rest of this over here. So we're going to take the square root of 16, which is 4. That goes to the outside with I, or outside of the radical. And the square root of 2 is left on the inside because we can't break that down anymore. So your answer for example 5 would be 4i square root of 2. And those are those are really the hardest examples that you'll get. So let's look at actually solving an equation by using this. So before we would always be able to take the square root of a positive number. Now we're going to look at when the square root isn't we're taking the square root of a negative number, and you'll see what that looks like. So on number 7, we've got x squared plus 81 equal to 0. We need to get x squared by itself. So we're going to subtract 81 on both sides. We'll be left with x squared equal to negative 81. And now the way we get rid of this square root, or this exponent of 2, is by taking the square root of both sides. So we would have x plus or minus the square root of negative 81. And now you can see that we're left with a square root of negative 81. So we're going to have to use imaginary numbers to solve this out. So x is going to be equal to plus or minus square root of negative 1 times a positive 81. And now we can take the square root of both of these. So we would be left with x is equal to plus or minus the square root of negative 1 is just I, and the square root of 81 is 9. So our answer would be x plus or minus 9i. And that one came out nicely because we could just take the square. We didn't have to break down 81 inside of the square root. Now I'll show you one where you actually have to break down the inside of the square root. So on number 10, we've got x squared plus 13 equals 1. And we need to subtract negative 13, or subtract both sides by 13. So we'll be left with x squared equal to 1 minus 13 is just negative 12. So to get rid of this exponent of 2, we have to take the square root on both sides. So now you can see we're taking the square root of a negative number. So when we take the square root of both sides, that leaves us with x is equal to the plus or minus the square root of negative 12. So first thing we're going to do is break down negative 12 as negative 1 times a positive 12. So that'll leave us with x is equal to plus or minus. We can take out I, because square root of negative 1 is I. And we'll be left with the square root of 12. I times the square root of 12. But we can break down square root of 12 even further. That would break down to 4 times 3, or the square root of 4 times 3. So then we can take the square root of 4, and that means 2 is going to come on the outside, so I'll rewrite the rest of this over here. So we're going to get x is equal to plus or minus square root of 4 is 2, so it comes to the outside. I was already on the outside, and whatever's left over stays on the inside of the radical. So our final answer would be x is equal to plus or minus 2i square root of 3. Now the last part of this is going to be a little bit more challenging to understand, and it involves the powers of I. Okay, so in general, I squared is like saying the square root of -1 squared. Anytime you have the square root of something squared, the answer to that is just whatever's on the inside. So, in general, it's a big rule with imaginary numbers that I squared is equal to -1. If we just had I to the first power, that's like saying the square root of -1. So our answer would just equal I. Now, when we go further than just saying I or I squared, there's just some patterns that go on, and there's a specific way that you can solve these out. And that's the last part of this. And like I said, it's a little bit more challenging to understand, but we're going to go over it even more in class too. So for example, we've got I to the third power. I to the third power is the same thing as saying I squared times I. We're just breaking that up. And if we took I squared times I, that's going to equal -1 I, which is just -I. So this is the process of taking these exponents and knowing what we know about I squared and breaking them down even further. So we'll do I to the fourth as well. I to the fourth is the same thing as saying I squared times, or I squared, and all of that is actually squared. So when you break these up and want to actually figure out what each exponent is, you have to break up that exponent. And so this would be the same as saying I squared, in parentheses, is -1 squared, and -1 squared is +1. And that's how you have to break down these exponents. So let's look at examples. So on number 3, we've got I to the 15th. So if you wanted to break down I to the 15th in terms of I squared, you could say, okay, I know I squared is -1, so I'm going to put that in parentheses. Now, there's no way that we could get, we would have to break this up in a specific way. So we would have to say I squared to the exponent of 7 times I to the first power. Because if you remember your rules of exponents, when I multiply exponents, I'm actually adding them. But when I take the square root of an exponent, I'm actually multiplying these two. So if I were to do that, it would give me I to the 14th times I to the first, which would end up giving me I to the 15th. So that accounts for I to the 15th. All we did right there was break that down even further. So now that we've done that, we know that this on the inside, I squared, is equal to -1. So that's going to be -1 to the 7th times I. -1 to the 7th is just -1 times I. So our answer is going to be -I. And hopefully that makes a little bit of sense. It's a little challenging at first to wrap your head around, but the more you do it, the easier it gets. So let's look at another one, 14. So if I were to have I to the 62nd, I could break that up by saying, okay, I squared in parentheses, because as long as I can isolate I squared, I know that I squared is -1. And we're going to do that to the 31st power, because if you were to take I squared, that means you're having to divide that exponent of 62 to get what is left over here. And that's going to end up giving us the inside being -1 because I squared is just -1 to the 31st power, which would just be -1. So that would be our answer. Now, the reason that we use that is for multiplying imaginary numbers. So if you look at 15, when I multiply 4i times 7i, it's like the same thing as saying 4x times 7x. If I were to multiply 4x times 7x, I would get 28x squared. Because if I multiply two variables, I just add their exponents. That's the same thing you do with imaginary numbers. So for instance, we got 4i times 7i. That's going to equal 28i squared. But we're not done yet because we know that one of the big things with imaginary numbers is I squared always is equal to -1. So we can simplify this to 28 times -1, which is just -28. And that's why knowing these rules for the exponents of I are important. Because let's look at 16. We've got -4i times 2i times -9. So the first thing you want to do is multiply all of your coefficients. And that would give us 72. And then we would have I to the third power because I times I is just I to the third. Now, we will still be left with 72, but we can break up this I to the third. We can separate it by saying I squared times I. Now we know that this I squared is -1. So our final answer will be -1 times 72 times I, which will end up just reducing down to, or simplifying to, -72i. And that is that's the process of doing these. I'm going to show you I'll show you 17. This may be a little bit of a longer video, but I want to just make sure you see all of these. So if I have an exponent on the outside of a parentheses, that means that exponent is applied to both 2 and I. So 2 to the third power is 8. I to the third power is just I squared times 5i. So now I'm going to multiply my coefficients, which is going to be 40, 8 times 5. And I'm going to also multiply I to the third times I, which would just I would add my exponents, which would be I to the fourth. And then I can break down I to the fourth by saying I squared in parentheses to the square root of 2. And then that would give me 40 times -1 squared, because I squared is -1. So my final answer would be 40 times -1 squared is just 1. So my final answer is just 40. So I know that's probably a little confusing, but we're going to work on some examples of this. The last one I'll show you is 19. So if I were to take two square roots, two radicals, and multiply them together, first of all, these are negative radicals. So the first thing you need to do is take out the imaginary number out of each of these. So both of these would break down into -1 times 18, square root of -1 times 18 times the square root of -1 times 10. So you can take the square root of 1 out of each of these, so it would be I square root of 18 times I square root of 10. Now when you multiply radicals, you just keep your radical sign and multiply whatever is on the inside the radical. So if I were to take I times I, that's going to give me I squared. Then the radical of 18 times 10, which would be 180. I know that I squared is -1, so this is going to equal -1 square root of 180. And I can break down 180. I can break that down into let's say I'd have negative 1 on the outside, and on the inside I'd have the square root of 36 times 5. And then I'll finish the rest over here. So negative 1 square root of 36 times 5 is going to break down. We can take the square root of 36. So 6 comes on the outside, and it's a negative 6. And then on the inside of our radical, the 5 would stay because we can't reduce that anymore. So the answer to number 19 would be negative 6 square root of 5. And those are going to really be the toughest ones. The back end of these notes are the toughest just because the powers of I, like doing the exponents, they can just be very confusing. So we're going to go over more examples in class, but that will be it for this video.